Good afternoon, everyone. Hopefully you can hear me over the race cars, and hopefully you don't think you're in the beer garden getting your Oktoberfest, because I don't actually have any beer to give you. Sorry about that. My name is Sean. This is Mike, one of my partners. We work for a company called Envo Solutions. If you can't guess, Envo is short for envelope. We're going to talk today about building envelopes, specifically air, vapor, and thermal barriers, and why they're important. So while Mike gets set up with a couple things here, you guys can try and guess what he's doing. I went to one of those big engineering schools and I got my degree, but where I learned the majority of what I'm going to tell you about was just from having 20 years experience in the metal building market. So this presentation will be totally focused around metal buildings. If you can't guess what a metal building is, it's the one in the middle. You're not going to have to answer any questions later. This isn't a quiz, but that's what we're going to talk about. Low-rise commercial, low-rise industrial, and how the building codes affect that. This is obviously a map, and it has different colors for each of the states that have adopted the different codes. So when I say code, I mean all of the IBCs, the International Building Codes. A subset of that is the IECC, or the Energy Code, and that's specifically what this map is. So right now we have states that have adopted 2021, 18, 15, and there's a few lagging behind. But the next piece that's coming is the 2024 codes, which we're also going to touch on moving forward. So getting right into it, the first thing we want to bring up here is, what is an air barrier? Air barriers affect everything in your life. Air barriers can be as simple as a bag of Doritos. When you open it, you've broken the seal. It is the Ziploc bag. It is everything in your life is an air or a vapor barrier, and it keeps everything fresh. So now we look at it with a building, and we look at all the ways that you can have different pressures on a building. So you've got pressure on a wall, pressure on a roof, and the air barriers stop that pressure from either coming into the building or leaking out of the building. Air barriers stop pollutants, your dusts, your smells. They can take on a life of their own, but really why we're here is because they're required by the building code. So no one wants to see their balloon deflate. That's an air barrier in the simple sense of a word. And no one wants to see their hot air balloon have a leak in it, because you're just wasting money. So with regard to the IECC codes, starting in 2015, air barriers were a requirement. There were 3 ways to meet the air barrier requirements in a building. First was the material requirement. The second was the assembly requirement. And the third was the blower door test. If any of you know what a blower door test is, it's big, it's scary, nobody likes it. So for 2015 building code and for 2018 building code, we've avoided it like the plague. Most of the manufacturers out there test their materials, they test their assemblies in isolation, and nobody wants to test the building. For 2021, there is a new piece to the code that you all have to be aware of. That's the one that most states are adopting right now. That is called the Building Envelope Performance Verification Requirement. That takes away your first 2 options. So it takes away materials and it takes away the assembly. It leaves you with the whole building, and it leaves you with the performance verification method. Now this is very, very important, because it's not as simple as turning in a little bit of paperwork. What it means is we need professionals, engineers and architects of record, to specify where these air barriers go, where they're connected, and how they're to be installed. The next piece of that verification is that it has to be tested continuously through the installation. Most air barriers are actually buried in a wall assembly, as we'll show later. So you can't go and visually inspect them in the end, because you can't see them, you can't feel them, you can't touch them. They're buried in a wall assembly. So first you need the designers to specify it. Second, you need to inspect it during the process. And the third step of building envelope performance verification is a final commissioning report. That means the architect or engineer of record has to sign off with their name, their stamp, their seal, and say, yes, it was done properly. So that's option 1. Option 2 is the blower door test. All of a sudden, that blower door test doesn't sound real bad anymore. Now, when we go to 2024, none of our states have adopted it yet, but as you can see down here on the bottom, the flow rates have gotten more stringent, and they've defined the documentation requirements even better, which means they made it harder. So before, you used to be able to document it slightly. When we get to 2024, the limits are lower and the documentation requirements are higher. One of the things that we have an issue with in the United States today, there's not a lot of teeth in our building codes because most of our local inspectors, local building code officials, don't actually understand the nuance. One of the things code is doing in 2021 and in 2024 is adding those teeth back in by becoming very, very specific on what those requirements are and defining it and putting it in writing. So even if you don't have it right now in your state that is 15 or 18, it is coming for 2021. It is something to be aware of. So this shows our path to compliance. We've got our whole building envelope test over here. Over here, we start with our materials and our assembly, and then we hit this performance verification. That's the important step for 2021. And there's the 3 steps I talked about earlier. Now, this is an IECC and an ASHRAE requirement. So unlike the thermal, you can't back out of IECC and go to ASHRAE and get a simpler design. It is in both. So one thing we talk about is vapor diffusion, and we talk about air leakage. So over here, we've got these 2 tents that you see. And right now, we've got a pretty good seal. So what I'm going to do here is I'm going to cut a small 1x1 hole in this, and all of a sudden, you can see how much more of this smoke is coming out of that 1x1 hole. Now, if you think about what a 1x1 hole is in your building envelope, when we're talking about metal buildings that are tens, hundreds of thousands of square feet, that 1x1 hole can do a couple things to you. Here's 7.5 gallons of water. This is what you're going to get through that 1x1 hole in your barriers just because of air leakage. Now that's going to go into your wall cavities. That's going to go into your crawl spaces, your attics. This is an actual problem. With vapor diffusion, if you have a good seal, we're only talking about a 1/2 ounce of water that's actually diffusing through your barrier products. That's really good. That 1/2 ounce of water is not going to affect anything. But you get 7.5 gallons of water every month into a wall cavity or into one of your spaces, that's a problem. So that's kind of the difference between a vapor diffusion and an air leakage. That's how important air barriers are in your assemblies.